Hello, everyone, and welcome to another episode of OpenObservability Talks. I'm Dothan Horvitz, and here at OpenObservability Talks, we talk about anything DevOps, observability, and open source. And I'd like to thank our sponsors, Logs.io, the cloud-native observability platform. For those joining the live stream on YouTube or Twitch, feel free to share questions and comments on the chat. It will make things much more interesting for all of us. And with that, let's move on to today's episode. In this episode, we'll talk about how much monitoring and observability actually cost us. We all collect logs, metrics, perhaps traces and other telemetry data, but this can get expensive pretty quickly, especially in today's microservices-based systems. And there's what everyone know about as the cardinality problem. And this is going to be the topic of today. My guest is pretty vocal about this topic, Ben Sigelman, co-founder of Lightstep and also co-creator of OpenTracing and OpenTelemetry projects. I'd like to invite Ben to the stream. Hey, Ben, how are you doing?
Hi, how are you?
Great. Glad to have you here on the program, on the show.
Yeah, my pleasure to be here. It should be fun.
Yeah. And by the way, by vocal, I mean it in the best of senses. I love your tweets and the way that you, I guess, provoke us in the community and get the conversation going and get us thinking about our approach to observability. And besides all the credits that I gave you in the intro, I also another item that is important in your career is that you are one of the people who architected Google's own metrics and distributed systems, distributed tracing systems. And it's interesting because I actually on this show had the privilege of hosting Ramon, a staff SRE at Google, and we discussed Dapper and Monarch, and we got the SRE, the user side of it. So it's very interesting, and maybe it's a good opportunity for you to tell us a bit about this fascinating background in observability.
Yeah, that's interesting. I should check that out. Actually, I'm curious. It's a little bit frightening to me that they're still being used. I realize that they're continuously under development, but I believe that. Yeah, I mean, we started tinkering with Dapper in 2004. I mean, it's like almost 20 years old now, which is really something. The paper came out in 2010. Wow. But I mean, the approach itself is showing some age, I'd imagine, within Google. But yeah, that's interesting. I'd love to hear that.
Yeah. So do you want to tell us a bit about yourself and your background?
Yeah, well, I guess we covered a little bit of it. Thanks a lot for the intro. I spent my formative professional years at Google. I went there pretty much straight out of college after a short stint as an intern at Microsoft Research, basically, and then spent 9 years at Google, where I was very unhappily working on ads for 2 years, and then escaped to work on what we would now call observability. It's kind of a funny story, but I was put in touch with, they had an event where they set you up with a completely random, literally random one-on-one with another engineer. And the one that they set me up with was this woman named Sharon Pearl, who was a pretty distinguished researcher who was working on 4 or 5 different things at the time, including like what ended up being sort of like a blob store, like S3 or something like that, some other storage systems. And then there was this thing that, she and a few others were tinkering with, which ended up being Dapper, basically. And I'm often sort of miscredited with having created Dapper. I wouldn't exactly say that. The initial experiments were run by Sharon and some of her colleagues, but they didn't. It was a kind of a proof of concept. What I did do is toil through the process of getting the kinks worked out and getting into production, stuff like that. And then I spent a while working on Dapper, which I really enjoyed. And then after 3 years of that, I decided to take on the metrics monitoring problem at Google, which I spent another 3 or 4 years on, which became Monarch. And then in 2012, I left Google, did some stuff for a couple of years that I can talk about if you want, but it's not related to observability. And then started Lightstep in 2015, and I've been working on this space ever since, and really enjoy it. It's incredibly dynamic and interesting. So it's been fun.
Cool. So I think just to warm up the discussion, I wanted to. You mentioned Google's days and what today is called observability, but there's a lot of confusion out there still about the difference between observability and monitoring. And I still remember your famous tweet about observability will never replace monitoring. So maybe you can help us understand the difference between the two, really, and why you think it will not replace it as a starting point.
Sure. So there's a lot of confusion about observability, probably partly because I think a lot of, especially more traditional / legacy vendors, I think have tried to recast whatever they have on the truck as observability, which is not making it any easier, I think, to get a clean read on what it actually is. A lot of people will cite the academic definition of observability, where observability was really like the kind of lesser cousin of controllability in control theory. I can cite that definition too, but it's probably, it's pretty academic and maybe not that useful. I think practically speaking, if we're talking about observability in distributed systems, which is probably what we are talking about here for cloud native and stuff, observability, I would say, is divided into two important value propositions. The first is connecting the health of some subsystem to the health of the overall application in the business. I think a lot of people would rightly refer to that as monitoring. And I think you're right. It drives me insane when people talk about observability replacing monitoring, or observability being a new word for monitoring. Monitoring is extremely important. There's still a lot of innovation to be done in monitoring, and it's an aspect of observability. So you need to be able to connect the health of a system to the application, whether that system is a microservice or a cloud dependency or what have you. And there's a lot of innovation to be had in the way we do that. I'd say SLOs are a form of monitoring. I think automating a lot of the toil around finding appropriate thresholds and what should be in a dashboard and what should be in an alert, that sort of stuff. That's all part of monitoring. But the challenge is that if you take the tools that you use to do monitoring and you try to apply them to understand changes in what the monitoring is measuring, that's where things get kind of sticky. And that's where the rest of observability comes in. I think you can, broadly speaking, say that remainder of observability is understanding change, both planned changes, so things like CI/CD is the classic example of a planned change, or unplanned changes like incident response. These sorts of changes often involve multiple teams, multiple services, multiple types of telemetry, and that's where observability gets really hard. But when we apply monitoring tools to observability, things tend not to go very well, and they get very expensive. You're the subject today, although we can talk about whatever as far as I'm concerned. But observability is the combination of these two things, both connecting system health to business health and understanding changes.
Yeah, that makes sense. And where do you see APM fitting into all this ecosystem?
That's a good question. I mean, I think APM is also, unfortunately, it's not like these are regulated words, right? So it's like people will call things an APM, and I'm not so sure I would agree. But I mean, historically anyway, I think of APM as being a tool that was sold to totally siloed ops teams historically, right? So it's like you had a dev team building software, they'd throw it over the wall, and then an ops team has to figure out what's going on. And in a sense, that's actually a very literal form of observability, in that you can't change the system, you can only observe it. And APM was actually really valuable in that it allowed you to see inside the black box of the software that these dev teams wrote, in a different part of the org and maybe a different time zone, as an operator, tried to uncover what was going on. And I think that made a lot of sense. APM, somewhere along the way, when you move to distributed systems, when people are talking about doing distributed tracing, I think that felt a little bit, that's a lot of syllables and kind of a hard thing to market. And so people would use APM to refer to distributed tracing tools. I don't make the rules. I'm not sure. I think it's a very good idea. But sometimes, like, just to name names, like Datadog APM is basically, their where their tracing technology lives, and they've wrapped a product around that, and they call it APM. I wouldn't really say Datadog APM is like a conventional APM. Like you wouldn't necessarily want to use Datadog APM if you had some 3-tier Java app running on top of Oracle or something like that, which is where AppDynamics, might have played really well 5 or 10 years ago. So unfortunately, the marketing terms, I think, are really, really confusing, hence this lengthy, winding answer. I prefer thinking about jobs be done, which, again, have to do with core monitoring and understanding change. A really good APM solution should be able to do both of those things, although most of them don't. So there you have it.
It's good because, again, I also experience this confusion in practically every other conversation I have out there. So I definitely understand. And I was curious to hear the way that you articulated, because we'll probably have to reiterate. And it's part of the incentives for which I actually started this podcast dedicated to observability, to try and filter out all the marketing buzz and talk about the essence of the different aspects. And glad to have you here with that. And let's talk about, we mentioned the cost of observability and the cardinality challenge and also these terms. Let's start breaking these terms down and saying what is the cost associated? Why is there a cost? What is that getting exploding so easily? Can you walk us through this?
Sure. Yeah. So regardless of whether you're using a commercial vendor or deploying open source, the cost for observability ends up being dominated by the collection and long-term storage of the raw data itself that's used for observability. So that raw data is referred to as telemetry, and it takes many forms, but the largest forms in terms of just data volumes are in no particular order. Metrics data, so statistical data gathered from these applications, logging data, which I think everyone knows what logging data is, which can take the form of both structured and unstructured logging, and then tracing data, which I think of as being kind of a cousin of logging data. It's very similar in that it's event data, but typically structured events and with context about where the transaction came from in the distributed system, if you're talking about tracing. But those 3 types of data, those are the brunt of the telemetry, and thus the brunt of the cost. And now it's gotten really painful for 2 broad categorical reasons. The first is just simply that as you add the point of cloud native, the whole purpose of it is not to build distributed systems. The purpose is to allow individual teams to operate with autonomy, right? So the idea is, like, if you want to innovate faster, you should be able to hire more engineers. And as you hire more engineers, you can't just put them all in the same service, or they just sort of start running into each other. So you build an application where the services are small enough that engineering teams can move with autonomy. Okay, great. So suddenly your team has grown to thousands of engineers in order to innovate faster than competitors or what have you. And those thousands of engineers are working on hundreds or thousands of microservices that are all out there in production. The reason that this cost thing got so unwieldy for cloud native is that the amount of data that's being generated is not just proportional to the number of business transactions or the amount of revenue that an application is generating. That's certainly relevant. Like, if you were to 10x the load on an application, I think you can roughly assume that you're going to 10x the amount of data it generates, broadly speaking. But you're also multiplying by the number of services. So as you go and both increase your top line in terms of application use, and then also increase the number of just engineers typing code and number of services that are involved, you're going to see an explosion in the size of the data itself. So to zoom out, the first category of cost, eruption really has to do with just the number of services that are being deployed and maintained in parallel. The other one is actually, interesting in of its own right, which is that, as I was saying earlier, it's problematic if you try to use monitoring tools to do observability. Monitoring tools typically are tools doing metrics. So, these are the things where you're generating charts and alerts and so on. the only tool you have available if you're using metrics, you're trying to understand why something happened, is to do filtering and grouping. So you have a line that has an anomaly in it. You'll want to say, well, I wonder where that anomaly came from. I'm going to group by, service or region or host or maybe customer if you want to go there. That grouping, when you click that button to do that group by, the underlying time series database has to have a separate time series for every single one of those groupings, and that's the cardinality problem. And it ends up being extraordinarily expensive. I've talked to economic buyers of metrics tools where they've had a single developer has added one line of code that's costing them $200,000 a year, steady state and that's totally typical. I mean, going back to my time at Google, Gmail, frankly, I think they were doing it wrong, but they had, their core latency metric for all Gmail use basically had 11 different dimensions on it. And I remember this very well. And the total cardinality, so that is to say the combinatorics of all these different dimensions, they actually had several of these metrics, but each one had 300 million time series values for one metric. So one line of code would turn into 300 million different time series statistics, each of which had to be stored, for a long time with, a lot of capacity. And for Monarch was a bit of a load test. That's why I remember it so clearly, because we had to do a lot of work to support that. I mean, we had situations where a single metric wouldn't even fit in memory in one of the shards of the Monarch system. So that cardinality problem is more self-inflicted, and I think there are the cloud native explosion is somewhat fundamental. The cardinality explosion is not. That's something that actually can be mitigated, and we can talk about that. But that second category of cost, I think, is also really problematic, and is we can talk more about it, but I think needs to have a solution, or we're going to end up in an ROI negative place for observability.
Yeah, and maybe if I just try and summarize for our audience, essentially, I think first of all, in today's cloud native systems, as you said, there are a lot of failure modes. Each incident, you discover suddenly a new failure modes, and developers keep adding tags. And the second thing is that maybe it's not a common knowledge of the common developer understanding the impact. For them, it's just, okay, I'm adding a label there for this specific need, but they don't understand that they actually are adding something that is cross-cutting across all the systems. Now you're adding a dimension that each and every time series will be impacted by it. So I think this is the part where you get the multiplication, and very quickly, obviously your metrics bill is out of control. So so it's the number of dimensions, but also which dimension. It could be dimension of your number of endpoints, which is maybe one thing, but you gave the example of a customer, or sometimes even a specific user, which you can have millions of these in, B2C case, in which so it's even a single dimension, but having so many range, maybe an open-ended range of values, this is something that you cannot sustain. So I guess, and this is something that at least I feel that is still not common practice or common knowledge with developers that are actually the ones sometimes adding this. Do you see that as something that is evolving in terms of the knowledge and or do you see that as something that needs to be handed over to DevOps within the teams? How do you see that in terms of the proficiency?
Yeah, a good question. I think for most scaled applications that have existed for a couple of years, there is I think an awareness that this is a problem. But in the defense of the person writing the code, whether you want to call them a developer or DevOps or whatever, it's actually quite difficult to know a priori how expensive a metric is going to be. I mean, there are certain things that are kind of a known anti-pattern, like adding a attribute for the identity of the end user, or something like that is a bad idea. And I think that's been well documented. But the trick is that it is combinatoric, right? So it's like you can have several dimensions that seem independently sort of okay, like maybe they have 100 or 1,000 values. But if you add all of those attributes at once, it's the combinatorics of those values can still get you way up into the hundreds of thousands or millions of distinct time series. And at that point, it just gets really expensive. And it's a lot to expect a developer to know ahead of time what it's going to be. And certainly this is useful. I mean, the reason why people add these attributes is that they have a hypothesis that this attribute might be the thing that explains some kind of, emergency in production, and they might be right. So there's
or that was yesterday's emergency, and that they're trying to protect for the future and adding the more additional dimensions there.
Yeah, exactly. Yeah, right. You do a postmortem, you realize that your service, which has 25 replicas, one of the replicas got really hot, and so you're going to want to be able to understand both which replica everything is coming from, and also some of the aspects of whatever that hotness happens to be, so that you can break things down. That's where this starts, right? It's always with the best of intentions, and there's usually a good reason for it. But that's just a really slippery slope and a difficult thing for developers to estimate. I mean, my basic point of view on this is that it's not reasonable to expect anybody to know what the cardinality of something is going to be as they're instrumenting code. And I would, it's not just like a fantasy, but I think we're in a position where we're only bound by our own ability to implement solutions here as from an observability standpoint. It should be possible for a developer to add as much cardinality as they want to the instrumentation, and then it's up to the observability system and the telemetry collection system to do the right thing and to be smart about that. And I can talk more about that, but I think the idea is the instrumentation should just reflect the business logic and not be constrained by these things. It is very important, actually, that the instrumentation be sufficient to diagnose things, because you really cannot afford to go back, re-instrument, redeploy during an emergency. Like the instrumentation, dynamic or static, needs to be able to get this data out. And I think that the problem we have is that it's kind of one size fits all right now. And for a lot of people, when they add tags or attributes, that turns into a bunch of high cardinality metrics, which is ROI negative. And that's the problem. And I think that's what we need to fix.
Definitely. And it's something that I've been trying to preach also, that, observability is essentially a data analytics problem, and we need to adopt this mindset and treat the data with the growing volumes with the same practices that we have. So you mentioned shifting the responsibility to the tooling, and that's interesting, because in the tooling side, you can start talking about something, things that are interesting, like the things that you've done in OpenTracing days, and others like obviously in Monarch and in Dapper, the sampling and the verbosity, things like that. So maybe you can talk about how you can optimize the data, and which different types of optimizations you see effective for that.
Yeah, it's a rich topic of its own. So when we're talking about the cost of the data, I think a lot of times people will say, well, you can always sample. And that's true, especially for event data. You can always sample, and that's one of the dimensions. But there are several others as well. I mean, I think if you're talking about the cost of data, there's the amount that you sample, and also when you sample, for what it's worth, because that can happen in many different places. There's the verbosity of the data, which you mentioned, which I think is often overlooked. Like, people have this idea that you either do or you don't trace something, and that's really not correct. I mean, you can choose to trace at the level of individual function calls, or if you wanted to, you could even trace at a finer granularity than that. And if you do that, as opposed to tracing HTTP calls, which is sort of the typical granularity, you end up with much larger traces, but also much more useful traces. When Lightstep was very, very young, like before our Series A in 2015, one of our initial customers was a really interesting startup that no longer exists, like a lot of interesting startups from 2015 or whatever, but they used Lightstep very effectively in what was ultimately a pretty monolithic application. I think they had like 3 services, not 300, but they used us to measure every single function call in a Node app, and they got a lot of value out of it. But it was extremely high verbosity distributed tracing, extremely high verbosity. And for some reason, there are these things like that ended up being very valuable for them. But I think the industry in general has kind of abandoned that, because if you trace every function call at scale in a big application, it just doesn't work. I agree, it's way too expensive. But what if you were able to say, well, 1 out of every 10,000 times, we're going to trace every function call. 1 out of every 100 times, we're going to trace this thing. And then 1 out of every 10 times we're going to trace the HTTP calls, and then 100% of the time we're going to propagate the context in order to do X, Y, and Z. And I mean, I've written a bunch about this too, but we have a very like unnecessarily binary idea of sampling, where it really sampling and verbosity have to play together. And then once you've taken that into consideration, there's the question of like, where do you collect the data? How long do you store it? And that's the final aspect. Storing data for 15 minutes is a different type of architecture and different type of retention problem than storing data for a day, 3 days, a month, or 3 years. And at each one of those, you would probably take a different approach to how and where you'd store the data, whether you'd plan for it to be accessible in real time or need to be rehydrated in some way. These sorts of considerations come into play as well. And that's another important aspect of understanding the cost for event data. Does that make sense? I mean, but that's kind of my mental model for the cost when it comes to event data, like tracing and logging data.
Yeah, I think I would add, you gave simpler examples about the statistical sampling, once in every 1,000 and then once in every 10,000. I would say that I see that even being more intelligent or context aware, in the sense that let's take the simplest example that I usually give in my discussions is that you obviously want to give higher importance and granularity and focus to 400 or 500 error codes than the 200 one. So when you know that something, at least on the face of it, is of higher focus, premium enterprise customers versus the free trial, I can give lots of examples where you can cut the benefit that makes sense to your business and your flows, operational or business ones. But then you can decide, okay, for these I'm taking higher granularity. It could be a higher sampling. It could be finer grain of the data included within the span. It could be a extra correlation that you put in metadata. So we can play with it, and I definitely agree with what you said. The combination of the sampling strategy together with the verbosity of the data that is found there has a lot more potential than what you had in the original paper in Monarch. I guess this is one of the things that frustrates me, that people got stuck on the verbal senses that are in the architecture presented there. And up till today, I see out of the box the 0.1% default sampling rate, and people copy paste that as if it's not a notion, but rather a literal thing that they need to stick to. So what you're saying is definitely resonates and shows it. Do you want to maybe say a few more words to understand really where we can take it with the verbosity and with the sampling from your experience with your customers and users?
Sure. Yeah, I will do that. I'll talk about the current day in a minute, but I will double down what you said. The Dapper paper, I think, which is where sampling stuff kind of is used as it's cited as like where this 1 for 1,000 or 1 for 1,024 sampling came from. Like, oh, well, Google did it that way. I mean, first of all, Google's not normal. I mean, I think their public number, which is way under the actual number, is 5 billion RPCs per second. So it's like, that's a big workload, no matter how you slice it. And there's a need for a lot of sampling just to control costs. And the sampling in Dapper was not to optimize for, like, it wasn't about overhead. It was just about the dollar cost of collecting the data and keeping that in some reasonable place. But yeah, as you said, it was totally dumb. Uniform random sampling, which is absolutely not the right way to do it. I don't think it's even how Dapper works today. I think they have thankfully improved that piece of it, but it's totally wrong as a default for almost any application. I mean, 1 for 1,000. It's unfortunate that it's taken on a default status, is because that's a pretty punishing sampling rate. You throw out a lot of babies with the bathwater if you go to that extent, right? Now, the other piece of it is that Dapper's implementation, I said it was about cost, sucked. I mean, it was reusing a pathway that was designed for local on-disk logging, where there are actual system calls being made that competed with the application itself to write data to local disk and then get farmed out over the network. And that was done for various reasonable time to market, so to speak, engineering concerns, and the fact that the code path already existed. But it's totally wrong. It's not how anything works today. And if you were to use network collection, which is what almost everyone does these days, even in the sort of the Google universe, you wouldn't end up with such an aggressive sampling rate. So suffice to say, totally the wrong number. Now, for Lightstep, I'm here more as a subject matter expert than as a vendor or as someone who has something to sell. But I will say, like, our overall effort here is on trying to move towards both sampling and retention being declarative and based on jobs to be done. I mean, I think a lot of the problem is that we're forcing people who maintain observability solutions to get they need to have enough training and expertise to be able to tweak sampling configurations and things like that, which are notoriously hard to tune, actually, just manually based on how they anticipate the systems are going to be used by the hundreds or thousands of development teams that are out there banging away. And I think that's a really unreasonable thing for them to do. I mean, rather, I think it would make sense for someone to say, look, I'm maintaining the system. Here are my SLOs. Here are my dashboards and alerts. And then, press apply or something like that. And at that point, that should be enough information for the observability system to actually kind of train their model on which data needs to be kept at very, high verbosity levels and high sampling rates, and which data needs to be kept at lower sampling rates and, lower verbosity levels. And it would be based on the declarative needs of the service owner. And then those things, of course, can be somewhat recursive because you have services at the top of the stack, depending on others. All the data we need to make those determinations exists. Lightstep has gone through and studied customers, especially for metrics, actually. And if you look at their configurations for metrics, and this is not like a extreme example, this is common. The extreme examples are more extreme. It's like 1 in 10 metrics is ever queried for any purpose, whether that's a dashboard, an alert, or an ad hoc query, over its entire lifetime. And the other 9 out of 10 are literally never used for anything. So I'm not even saying whether those queries are valuable or necessary. I'm just saying like 90% of the data is literally never accessed. And it's just like, in my mind, is this egregious issue. But to address it, it's not a matter of giving the platform team a profile. They need a profile as well as some suggestions on like which, no one wants to delete data someone might need in an emergency. So you need to train it on the actual usage of the data. And I think where we're falling short as an industry is that our solutions are not closing the loop to the usage of the data over a multi-month period in order to actually illuminate, which metrics, which tags are needed and which are definitely not. And then put the people in control of the systems, give them all of that data so that they can, opt in to pre-aggregating or sampling away data that's unlikely to be used ever.
Yeah, and I can definitely say that I see the same, and we see the same also in my company at Logs.io, and it's, I guess, very prevalent that you see people collect everything because it may be useful one day, but actually you see that a very small fraction, I don't know, it's 1 out of 10 is very big number, but I definitely see a lot of them unused. I think there's another aspect in the metrics, which is the roll-ups. So you do the roll-ups on that, and then obviously you lose the granularity of the data. And then people also are concerned that, okay, but I know it only in the granularity of, I aggregated and I rolled up across all of the nodes in the cluster. But what happens if I now need to do the drill down? I can't go back. I can't revert. So how do you see the balance between, as you said, all the raw granularity and the usage of rollups in that context and the aggregations?
Yeah, that's a really good question. So, and by rollups, you mean, like I want to group by, something that's, well, I mean, I think that let's just be specific. Let's say that you own a service and you're looking at error rates. So the ratio of errors to normal requests over time. And I think the chart you'd probably want to have is just in the aggregate for my service and production, what is the error ratio over time? And it turns out you're actually collecting this on a per host level. So if you needed to, you could do a group by host or filter to a certain region or something like that. But at the first approximation, you just want to see the overall error ratio over time. Is that the type of thing you're talking about?
Yeah.
Yeah. So this is exactly what, we're going to stretch the limits of, I think, what can be done verbally here, but I'll try to be clear. This is a huge point in my mind. And when people talk a lot about like unifying metrics, logs, and tracing, which is a bit of a trigger for me because those are not products, they're just data types, right? But I do think they need to be unified as data types. But right now, for a lot of, I would say, not a lot, it's an understatement, almost everyone who's like actually trying to do observability out there in cloud native, you have, if not a separate vendor, at least a separate tab for a dedicated exploration of these different types of data. And I think that is actually what's driving a lot of this, is that if it takes a full context switch from a metrics dashboard into some other tooling in order to understand an anomaly in metrics using logs or traces or whatever, if it requires a full context switch, that's pretty painful. And so you're going to try to find a way to use metrics to solve your metrics problem. And that's why people will add attributes that end up being high cardinality and expensive. And it's why people are nervous about throwing them away, because there's this idea, well, if I can't do a group by in a metrics tool, then if I run into an anomaly I can't diagnose with metrics, I have to basically restart my search in a totally different type of tool, for logs or traces or whatever. That is a failure to execute, I think, from like an observability platform standpoint. I mean, what you should be able to do is look at a metric, which is a fine place to start. I think metrics are not going anywhere. They're appropriate for the first line of defense. You're looking at a metric, there's a spike in your error ratio. At that point, there's your tracing data, not to mention your logging data, probably also pertain to that same application and should also have information about transactions that did and did not succeed during the failure interval as well as in the baseline. And there's no reason why the observability tooling shouldn't allow you to do a time series chart and a group by using these more event-oriented types of data, so logs and tracing. So the problem is that the observability tooling doesn't guide you from your analysis of metric monitoring over into these higher cardinality and I think more appropriate data types for investigation. And that's where we're failing. I think that we've managed to build observability solutions that at least will have a single billing contact for the different types of data, but the actual workflows require a full context switch. And that's not acceptable in my mind. And this is why there's so much pressure to do high cardinality metrics, because that context switch is too hard to do dynamically.
Interesting. And we should say, and especially here, I'm trying to highlight the open source aspect and open standards primarily. I think it's we owe a debt of gratitude to yourself and many others in the community that pushed standards such as exemplars to bring the signal types together and be able to correlate it as part of the specification itself. So the specification itself should have it built in to be able to cross-reference. Obviously, the backend tooling, the analytics tool needs to support it in a native way and not having to jump between different tools to achieve the job. But I think
exemplar is important. I think it's not like no one ever talks about it, but one of the most important aspects of this is actually just the standardization of semantic conventions, which is like a fancy way of saying the way that we name attributes. I mean, if all we do is just use a consistent set of keys and values to name the same attributes in metrics and tracing data, that's a huge win for this problem. Because the tooling right now is unable to do its job if it can't use those attributes to perform that join in the background. And I think exemplars are great, and I have no objection to it at all. That being said, it's really kind of a hack. Like ideally, you wouldn't need exemplars in the metrics. The system should be able to look at the attributes in the metrics and the attributes in the traces and just realize that they're talking about the same thing, because we have semantic conventions that dictate that. And that's actually a much more flexible and extensible way of solving these problems too, particularly for infrastructure metrics. So I see the open source, the open sourceification of telemetry is a really important thing to reduce vendor lock, which was like the first aspect of it. But I think it's going to go a lot further once the semantic conventions stabilize and really proliferate, because these sorts of joins will be possible for any tooling, open source or otherwise, and actually work in practice.
Yeah, and I think this is where I see also a lot of the benefit of OpenTelemetry, and I know that you're one of the originators of this project, important project, or more specifically OpenTracing, that then merged into OpenTelemetry. So even it's a predecessor in a way. But I think even last month I hosted your Alolita Sharma, and one of the things we discussed is now that the most problematic signal, logs, that is the most unstructured, unfortunately, traditionally, is now OpenTelemetry as a project, as a community. We're trying to now take a stab at this one, and in combination, but in collaboration also with the ECS, Elastic Common Schema, and trying to put an order into logging. I think this will make a huge leap into that. And
Agreed.
Even today with OpenTelemetry, that you have built-in Python libraries and log appenders in Java and others that allow you to inject tracing data like the trace ID and span ID and service name and so on into the existing logs, even traditional logs. So to try and bring them together, these are all small steps, but important steps in bringing us together.
Yes.
So I want to go back to the point that you mentioned before, and we talked about essentially having, I guess, three vectors of optimizing the data. We talked about sampling, we talked about verbosity, and we talked about the retention in a way. So how do you, what's your best practice when you come to a customer, to a user, to help them juggle these three vectors or elements in order to optimize?
Oh gosh.
The tricks of the trade. We want.
Yeah, I mean, it's a tough one to summarize, but I will try to be brief. I feel like I'm being a little long-winded today, but in the spirit of trying to be thorough. But I think that, so let's separate things out between statistical data, so metrics, and the like tracing data or logging data. I think that might be more event oriented. For the statistical data, I'm really trying to help people understand that, as I've said a couple of times now, using attributes in metrics to understand more than what's needed for what I would consider to be monitoring, which kind of defined earlier, is something that should be done very cautiously or not at all. I think it's important for observability to and other signal types to take the practitioner, the SRE or DevOps engineer should take them the rest of the way if their metrics are not sufficient to actually understand an anomaly. Like that's a time to pivot over to other forms of data that are more appropriate for that analysis. So that's the metric side of things briefly. But I think your question, when we're talking about things like sampling and verbosity, we're usually talking more about event-oriented data like tracing. Our recommendation on that front, I think, is that there should be, long-term storage that is pretty diffuse, almost uniform, in order to do ad hoc queries and get a baseline for things that happened in the past with very little foreknowledge of what you might want to be baselining, right? There's one of the challenges in distributed systems, I think, is that, I've, as an operator myself, or as an engineer myself on call, there have been times, I'm sure other people can relate to this, where, I've been woken up about something, the kind of proverbial middle of the night situation, and I'm panicked, as one would be. And then I start digging around at something I haven't looked at before, and I don't have familiarity with what's normal. And I see something like, wow, this is it. This is totally wrong. And then you start digging further and you realize it does seem really weird, but it's been like this for like a year, and it's actually normal. So on to the next hypothesis, right? But it's very, very important in these systems to be able to quickly baseline almost anything that you see, because it's the fastest way you eliminate a hypothesis is by realizing that, strange as it may seem, it's been that way for a long time, right? And then you can move on to the next thing. You might want to come back later and figure out why it's acting that way. But I think baselines are really important. So there needs to be some kind of, hopefully relatively low cost and pretty uniform way to do a baseline of historical information. I think SLOs, if they've been implemented, are an incredible signal that something is super, super, super important and deserves to be kept with very high fidelity, high verbosity, high sampling rates or low, you should retain a lot of the data and keep it for a while. And then there's everything else that's in between, which is why it's to be a long answer to go into that. And for us, I mean, from a commercial standpoint, that ends up being a conversation with the team and the way that they do things. I think ideally, hopefully, within the application, although each group is different, there's a paved path and a way of building services that's somewhat standard. I think Spotify's done a lot of work with Backstage that helps you to understand which aspects of the service are typically important, and that's where we would want to invest our instrumentation budget or our verbosity budget. But unfortunately, it's case by case, and I don't have like a simple rule of thumb.
No, it's fine. And we have actually some interesting comments and questions from the audience. We have Jurasi here, a faithful member of the community, and he asked about storage and what are the promising contenders for an open source observability storage, in your opinion?
Oh gosh, I'm a little reticent to I'm a little reticent to like name names and to make it seem like I'm picking favorites, but maybe I can talk about some of the attributes of the things open source that I'm kind of fondest of, or patterns that I would look for. My biggest concern with really any kind of backend storage system for telemetry data is the capacity to do two things. One is just to distribute the storage in a way that's super, super horizontally scalable. I think the Monarch paper that finally came out well after I left Google actually talks a bit about the scale that Monarch had to handle, but it was, order of tens of thousands of nodes of horizontal scalability for the thing that's sort of the workhorse in that project. So that's thing number one, which is sort of obvious. But despite it being obvious, there's still a lot of things out there that don't horizontally scale very well, right? The other piece, and this is, I think, maybe a little less obvious, but just as important, is the capacity to actually push the queries very close to data. I think the most common architectural thing I notice about some of the open source systems is that they don't do a very effective job at pushing down important types of queries close to data. So the trouble is that if you've sharded your database like that, you can't actually complete the query close to data. You can only partially complete it close to data. Then you send summarized results back up the stack and complete them closer to the client who issued the query. I have seen that some of the like the kind of current crop, the current generation of relatively new open source time series backends have accomplished that. But it's a really important thing. And the problem is you don't realize you need it until you're pretty far down the road, right? So you can get like pretty far with a bunch of open source time series stuff. And then a year or two in, you can realize, oh gosh, this is actually really slow or not sort of sustainable from an operational standpoint. So those are the things that I look for. And then the final thing, which I haven't seen a lot of in the open source sphere, but I think is a matter of time, is the capacity to both scalably handle time series statistics as well as more structured event data in a single computational model. I think of that as being long-term, like where the industry is headed, and something that it does feel like a matter of time, but I don't think we're quite there yet. And I'm looking forward to that. I feel like that'll be a big step for the industry.
Yeah, that actually answers, I think, another comment that Jurasi said there in the chat that I see. If you could request the universe for anything, what would be the perfect observability storage look like? So I think you touched upon this question as well with our wishful thinking. And I do think that we're making some progress and important steps towards that. That's.
I'll have one more I'll throw in too, which I think, it goes hand in hand with my comment about moving storage and queries close together. But with the move to multi-cloud and the move to various other types of SaaS providers, that infrastructure SaaS providers, where it's kind of like a serverless model or something like that, where they're running in public cloud or private cloud, doesn't matter, but they're like somewhere else, but they're still part of your application. It's actually surprising. I mean, I won't name names, but like I've talked to some customers where, they're really big household name enterprises, and they're spending as much, this is not meant to be a dig on Amazon, it's just a fact. They're spending as much money just literally sending data from AWS into their observability system as they are in the observability system, because the volume of CloudWatch data is so enormous that just for everyone to make their margin on the network transit, that's kind of what it involves. And in order to get around that, they've taken various steps. I've seen this play out at many other customers too. Again, this isn't meant to be a dig on Amazon. I think it's just, these are just laws of physics and it's a lot of data, right? But what would be much more appealing, what they end up doing is either spending way too much to send data over the network, which sucks, or they create a totally separate observability system just for their AWS data, which is also just a terrible developer experience. What I think would be really nice is if, open source or otherwise, if the storage systems are able to do the storage and query over even historical data in a way that's like network local and prevents the data from having to transit over the wide area network. And then you could issue a query that would join data from, let's say, CloudWatch with your own services running, in Kubernetes somewhere else. And that could all just work. And there's really no fundamental reason why that doesn't work. Like Monarch certainly was built to execute queries in that way. What we would have to do though is have kind of like, pools of these query engines like running in different places with different ownership and having a chargeback model and so on. But if Drassi's asking like what my fantasy would be, it would be that where you can have the data and the computation living close to each other and then have final query analysis and query execution centralized across these different pools. And I do think that's possible, and the economics are such that I wouldn't be surprised if it happens, actually.
It gives me a flashback from the Hadoop days and the revolution of the big data and this, but that will take a different discussion.
No comment on Hadoop.
Anyway, I think we're about to run out of time for this part, and I want to leave a bit of time for the breaking news, and I'd be more than happy for you to join me on this part. So let's add some interesting breaking news. And the first one is closely related to the discussion about cost. We had an announcement of a new open source called OpenCost. That's essentially an open source collaboration on Kubernetes cost standards. It aims to standardize the cost tracking, allocation, methodologies, all the measurement, and help the teams using Kubernetes more easily understand their infrastructure costs. It started by OpenCost, by KubeCost, but other important members are there in the initial team, including the big names, AWS and Google and Adobe and SUSE and many others. And the bottom line is to provide guidance across various in-cluster resource types, and that will allow you to get provision standard cost models and best practices baked into that. I'm curious about your take. You mentioned Kubernetes just now. How do you see that new initiative?
Yeah, I'm in favor or whatever. It's not like I have any opposition to it. I would say that since my vantage point often has to do with tracing, I just want to very briefly mention, I think it's academically sort of interesting that, Dapper's code path at Google is not really owned by, from a resource standpoint, the people working on it, at least when I left Google, were all in the storage team. And that's because Google found that the most financially beneficial application of Dapper was to understand the cost of storage systems. And it had nothing to do with like the usual performance analysis use cases people have for tracing. Rather, getting back to sampling and verbosity, the lowest verbosity thing you can do is just to track context as it propagates through a system. At Google, they track every single request with no sampling to figure out which Google SKU, and there are a couple thousand of them at the top of the stack, caused which syscalls to happen at the very bottom of the stack in things like storage systems. And by doing that, they can like very carefully bin pack quota for individual Google SKUs at the level of storage. So when you get to things like KubeCost or the OpenCost work, I think it's really promising. My fantasy is that we can get to a place where the workload attribution is there too. And that actually comes back to OpenTelemetry, ironically. So I think context propagation and baggage was designed specifically for this type of use case, because ultimately you're going to see, oh gosh, Kubernetes is really expensive. Which part of my workload is actually causing that to happen? And that we have to use context propagation to solve that problem too. So that's how I see these things co-evolving in the future, and I'm very excited about it.
I definitely agree, and we'll double down on that. Actually, in a previous episode, I had the privilege of hosting Yuri Shkuro, who you know very well from the Open.
Oh yeah, totally. Yeah, Yuri did some great work on that for sure. Yeah. Yeah.
And the topic there was how distributed tracing and essentially the mechanism of context propagation could be put use far beyond just IT operations and into use cases of FinOps and BizOps and anything like that. And you mentioned cost attribution and resource attribution and so on. So that was a whole episode dedicated to that. So I wrote about it in a few places. So I definitely agree with that, and it's a good point to make. And if I mentioned Yuri Shkuro, actually one of the interesting bits that I collected for the news is a new research paper that Yuri, now part of Meta, of Facebook formerly, wrote members there about maybe a different approach than OpenTelemetry to the problem of semantic conventions. And Meta seemed to be taking a schema-first approach. I will post the research paper here on the chat, but I was wondering if you were able to have a look and if you have any initial thoughts about that.
Yeah, I will say it's on my reading list. I mentioned this before we started recording, but I got COVID last week, so I didn't read it last week like I'd hoped to. But I'm on PTO next week, and I will read it then. But yeah, Yuri's fantastic, and I'm actually really excited about that. I'm sure it'll be interesting.
Yeah. So we all need to add it to our deep reading list, and all the listeners as well. If you have any insights after reading that, it'd be interesting to follow up and discuss. Another one last topic. Again, last episode was about OpenTelemetry dedicated with Alolita Sharma, and I saw just about after the recording of the episode a tweet by Chris Anisik about working on a CNCF project journey report, and he actually tweeted there on that tweet a piece of that showed the ranking of contributions to open source. By the way, Lightstep came up very highly ranked in the auto code contribution. For me, it was a true evidence for the power of open source community to collaborate, especially under the CNCF that facilitates it. So this was for me very impressive. I was wondering if you had the chance to look at the data there.
I have seen similar things in the past. Again, citing my COVID infection, I missed everything last week. But I would say it is a great collaboration. Jurasi is, working for a friend of me at Grafana and is also on the governing committee with me for Hotel. And yeah, I mean, I'm really pleased by how collaborative the project is. I think none of us really wants to take any credit for it in particular. I think we're all just kind of pecking away at it. But it's a big problem with a lot of smart people. It's a lot of fun. So I enjoy it.
Yeah, that was, for me, that was, whoa. I know the people and I've been, interacting with them, but suddenly seeing the data, the raw data, and over time, the trend, and seeing new companies starting to get involved and make an impact.
I mean, the thing that's hard to capture in those commit statistics, but I think is actually much more noticeable to me, is the amount of end user adoption in the past year is just night and day. I mean, well, I shouldn't say night and day. There are definitely people using it in earnest last year, but I mean, I can't have a conversation with a prospect or customer or whatever where they don't already know about OpenTelemetry and they're not already using it somewhere. And that is definitely, it was not true like 18 months ago. And that's been really interesting and very encouraging. So that's kind of ultimately what this is about. But I think the fact that a bunch of stuff has finally reached stability and has gotten to that point has allowed end users to adopt it in earnest. And that's a really positive sign, I think.
Yeah, definitely. So I think we're about to run out of time. So I wanted to thank you again, Ben, so much for joining me on this show. It was a fascinating discussion. Thank you very much.
My pleasure. Thanks for having me.
And of course, I want to thank all our listeners and audience on the live stream or on the podcast apps. As always, all the episodes are available on all the favorite podcast apps or on YouTube. So feel free to check them out. If you are listening to the episodes on the podcast apps, do know that we stream the episodes live on Twitch and YouTube Live. So join us on Twitter at OpenObserve to find out about the next live stream. And you can also chime in with your comments and questions. That makes things much more fun. And follow up on Twitter or me at Horovitz, HOROVITS on Twitter to get more information about that. And of course, if you are an expert, domain expert in the topics of DevOps, observability, and open source, and you want to be on the show, feel free to submit a proposal, and be happy to have more members taking part of that. So check out the website openobservability.io for the CFP, or just reach out over Twitter. With that, thank you very much for listening. I'm Dotan Horvitz, and see you on next month's episode.